Every composite number can be expressed. We'll take some composite number, some 29 I'll take, okay? Yes. By which number it is divisible? No number. So it is nothing composite. It is not composite, it is prime. Okay. So let us take 32 then. If it any number you can take, okay. So 2, 16, 2, 8, 2, 4, 2, 2 to the power of 5. Wrong number I had chosen. But it's okay. So it is all are prime numbers. So 32 can be written as 2 into 2 into 2 into 2. 5 times I am writing, but all are prime numbers. Then we'll take some other number. 65 I'll take. 65 number 2 as 65 I'll take. This number is divisible by 5. We know 5 13s are 65. This is also over. Then no need of teaching this one. 1. So 65 can be written as 5 into 13. But this is a prime number and 13 is also a prime number. It don't have factors more than 2. So this is also. Now I want means from that one number I'll take. From which one? 5, 10, 92. So many numbers are there. No, here 510, 92, 306. Let me take 306. Okay. Now what is that 306? With 2 table it is possible. 2 table 15 and 3 153. Then with 2 table no. With 3 table yes it is possible. 1 plus 5 6, 6 plus 3 9. So sum is coming in the multiples of 3 and it is divisible by 3 table. So 3 5s are 15 and 1. Okay. Then again with 3 table it is possible. Okay. Why? Because 3 17s are 51. Then we can do this one or we can leave. 17 table you can do or you can leave. But some teachers will teach till getting 1 you have to do like that. But here I know that it is a prime number, it ends there, but anyhow we did it. So this 306 is nothing but, what is that? 2 into 3 into 3 into 17. Or you can write this in another way as 2 into 3 square into 17. But what this fundamental theorem of arithmetic says, every composite number, either 32 or 65 or 306. 3 composite numbers I took. 29 is prime number. That cannot be. If you want write 29, that can be written as 1 into 29. That's all. So can be expressed or factorized. Yeah, I factorized here as a product of primes. And its factorization is unique. What is the meaning of factorization is unique? That means in this how many numbers are there? 2, 3, 3, 17. That numbers only will be there. Order may change, that's all. Here I could have done first with the 3 table or 17 table itself I could have done. Either I can do with the 3 table or 17 table in the beginning first itself, or I can do with the 3 table or 17 table. Then also the order only will change. In which apart from order in which the prime factors occur. So 32 is going to have 5 2's and 65 is going to have 5 and 13. Only 2 numbers will be there. Either you can write as 5 into 13 or you can write this as 13 into 5. That's all. Order only will change. What are the numbers present in that will be unique. The numbers are unique only. 1 time or 2 times, how many times it occurs, that will be same. The number of terms, the number of items or in that, it will be same only. That is the meaning. So there is fundamental theorem of arithmetic. Every number we are going to. Why they are saying no? Suppose you leave here 51. You are thinking that is prime number and leaving there itself and writing 2 into 3 into 51. Then it is wrong. Because 51 and these factors are not 2 into 3 into 3 into 17. So someone else does means they will get this prime factorization. But if I am doing wrongly, this I will get 2 into 3 into 51. That's the difference. So if you are doing it perfectly, you will get the same number of numbers present in that one. That's all. That is this meaning. That's all. So no need to memorize that one or anything. Just you can say simply, if you take a composite number and do into prime factors, some numbers will get that are all will be prime numbers and they will be unique. Separately it will be there. That's all. Now, theorem 1.2. Let P be a prime number if P divides A square, then P divides A. That means, yesterday we have done in some sums. That means, if 16 or 4 is divided by 2, this thickness is more. Okay, 4 is divided by 2, nothing but 4 is, that means 2 square. 4 is nothing but 2 square is divided by 2, then 2 also will be divided by 2. Not only this is for 2 square alone, if 2 cube or let it be something, 2 cube is divisible by 2, then 2 is divisible by 2. That means this is A square, P divides A square. A square is divisible by P, then A is divisible by P. For that, this example. Now you take one more number, A square, some other number. 9 square is divisible by 3. Okay, not 9 alone. I took 3 because 9 square is divisible by 3 only. Then what about that 9? 9 is divisible by 3. This we are going to use in this theorem. Okay, that's why this lemma or theorem 1.2 is used. So just you can say, but it should be prime number said. Which one? This must be prime number. If any number is divisible by prime number, then that is square number is divisible by a prime number, then that number also divisible by that number, prime number only. So that's this meaning is square number and number. A number and its square we can call. Okay. Next question is what? Now show that 5 minus root 3 is irrational. Okay. Suppose you want to prove this 5 minus root 3 is irrational. What you are doing? No. Let 5 minus root 3 equal to A by B. Okay. Bring A by B here. 5 minus A by B. If root 3 goes here, it will become positive. Why I am taking that side? No, to make it positive. 5 minus root 3 is given. 5 plus root 3 is given means no problem. We can take only 5 itself. Very clear? So if 5 plus root 3 is given, you can take 5. No problem. But here minus root 3 is there. That's why I took minus root 3 this side to make it positive. And A by B, no problem. It can come inside. Now this can be written as 5B minus A by B. Okay. So that is root 3. Now, what is that? Here no need to prove anything. Why no need to prove anything means we have already proved that root 3 is what? Irrational. Correct? Now, sir, in the exam, if they ask, no, root 3 is irrational. How root 3 is irrational? Using this method, you have to prove again. The first method we have done on this method, we have to prove using this method. Take this one, consider root 3 is rational. The same steps, everything you have to do in the exam. Finally, you have to prove that root 3 is irrational.